We will have the final test tomorrow. So this is your chance to get any questions clarified. So I leave open for any questions. So I already mentioned the format of the test. It's open book, but you don't need more than a couple of hours or 1 hour maybe, because it's all going to be short answer questions, but I've given you a window of a few hours. No proofs, no designing algorithms or any such thing. Just to test your conceptual understanding of various data structures, graph algorithms, NP completeness, and all that. Okay. Any questions?
Hello, sir.
Yes, go ahead.
Sir, it is general question. Is certificates are issued for this test, sir, and for this course?
Yes, there is. So last couple of times what we do is that if I don't remember, so you should have gotten at least something like 40-50%. I forget what it is to get the certificate. So there will be two kinds of certificates. One says that you completed or you did well or something. Another one will say you attended it. And the minimum requirement for attended would be at least, I mean, we will see the final evaluation and look at it and see where there is a sharp drop. So I expect about, you should have gotten something like 35-40% in the overall scheme to get attendance certificate.
Thank you, sir.
I am working with the NPTEL team to see if we can get some sort of an FDP credit. But at the moment, they don't have it because, they want a proctored assignments and exams. In this course, we have not been doing anything proctored. So, but they're still working with AICTE to get some FTP credit for not just for this course, a couple of other courses as well.
Sir, video recording is available later also, sir?
I would think so. Yamini, are you able to access the video recording from last offering?
No, sir. After the course ended, I was not able to access. Only after joining as a TA for this batch, I was able to access.
That's different. But I see. So that means you have to download it and keep it in your
Yes, sir.
Okay.
Okay, sir. Thank you.
So it is good that if access is provided for at least 1 month, sir, after the course.
Okay, I'll check and request them and maybe ask them to send an email appropriately.
Yes, sir.
Any questions, comments, anything? I mean, anything you would have liked differently? I don't know how many of you really got a chance to look at the videos seriously. I know many of you, particularly faculty members, may get busy during the semester, but yeah.
Sir, I have a question on red-black trees.
Sure.
I confess that I did not seriously dwell into that part after that first time I watched the video, but something I thought, some ideas came to me.
Okay.
Sir, root should be black in red-black tree.
It is a convention. You can always make it black if it's not black, and it will still satisfy all the constraints.
Yes, sir. The two constraints are root, the red cannot have red child.
Correct.
Right. So, suppose I got a sequence, say 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Mm-hmm.
So I start with 10.
Yeah.
I insert as root,
Right.
and I color that as a black.
Okay.
Then I get 9.
Right.
So it goes to the left.
Right.
And I want to color that black because I'm not violating any constraint.
No, you will violate a constraint if you color it black. There will be a violation because, do you remember the black height property?
Yes, sir.
Which tells
Any path, it should be same.
the number of blacks in any path from the root to any external node should be the same. So if you look at this path,
Okay.
the number of blacks is 2, whereas here it's only 1.
Okay, got it, sir.
So you will violate it. So you have to color it red.
Okay. Done, sir. Yeah.
Okay. Yeah, the black height is a very non-trivial constraint. Yeah.
Yes, sir.
The red does not have a red child is something very local. That you can look at the parent and decide.
Yes.
Black height has some global, some sort of a property. Yeah. Yeah. So important thing is all these, whether it's this red-black constraint or the AVLT constraints, the goal is the same, to make the height log n. So apart from the binary search tree property, you bring in another structural constraint which ensures that the height is order log n. So then after every insertion and deletion, you need to make sure that structural constraint is also maintained. Okay, any other questions?
Good evening, sir.
Yes, Santu Saha. Yes.
I have a question that in matrix chain multiplication,
Yeah.
first we decided that what is our last multiplication,
Correct.
this choice, and then we are deciding that some recursive formulation we have got. Then we have decided the number of sub problems.
Right.
Here you said that means we got two sub problems. They are M1 to MK and MK plus 1 to MN.
Correct.
Then we are solving that sub problem individually optimally. Then you are saying that during you are describing the optimal substructure property.
Right.
Here you said that in the final optimal solution M1 to M2 to MK plus 1 MN, if
individually must have been done optimally.
then you said that M1 to MK not if not multiplied optimally.
Right.
Then we replace.
Correct.
That part I want to clarify that I didn't get that part.
Okay, I'm so glad you remembered so much. Very nice. Okay, so we decided that we are going to do first this, and then this, and then multiply. The last one is this, right?
Yes.
So the claim is this is what is optimum substructure, that this must have been done optimally
yes.
individually. But suppose not, right? So in the optimum solution, that you did not do this optimally. Suppose this is some suboptimal.
Yes.
Now let's look at the total cost, right? I mean, maybe this is done optimally, it doesn't matter. Okay. Then let's look at the total cost. You are going to spend whatever. Yeah, so whatever cost to multiply M1 to MK plus cost to multiply mk plus 1 to mn plus whatever the dimension, right? Because you will have the finally this matrix and this matrix, you have to multiply A, B. So that dimension would be something, I don't remember what notation I used.
D0, dk.
dk times dn,
Yes.
right?
Mm.
So this is the final optimal cost, because this is the optimum way we said this.
Yes.
Assuming that this was the last multiplication we did. Now, if this was not done optimally, or any of them is not done optimally, if this is not optimal, what does that mean? There is another way to multiply M1 to MK with cheaper cost.
Yes.
So now suppose I replace your way of computing M1 in the optimum. You have done M1 to MK. I replace that by the optimum. I'm giving you a different scheme where you said this is not optimum.
Yes. Yes.
You said this is not optimum. So instead of that, I'm going to replace that by the optimum. And then I'm going to do this plus this. That cost will be less, right?
Obviously.
Because this is less than or equal to this. This will be less than or equal to cost of this. So now if I choose the optimum way and then do the way you did MK plus 1 and then I did this, that cost overall would be less than this final optimal cost, which is wrong, because then that contradicts the fact that this is optimal.
Optimal. Okay. Yes. Yes.
Right? That contradicts the fact that this part overall thing is optimal. Yeah. So that means that individually each one must have been optimal.
Optimal. Okay. Okay. I got that.
Yeah.
And another question is closest pair. Yeah, there just strip is there.
Yeah.
Uh, that is restricted with delta 1 and delta 2 values. Okay. If one point is in left, I have median and strip is there. Then one point is in left side and one point is in the right side. And that is there any chances that that point means distance conclude that that is minimum?
No, because that distance will be more than delta, right? That's
Yes.
strip.
Okay.
So what
Oh,
is delta? Delta is minimum of delta 1, delta 2. I forget again the details of that. Yeah, because if you have a point here and a point here, this distance will be, it doesn't matter where they are, it will be much more than that delta.
delta. Okay. Okay. Okay.
That's why it's enough to look at only that strip.
Only that portion. Okay. 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 Thank you, sir. And is there any plan to that include that? I have done that hashing part also, but I thought that if you said that up to open addressing and double hashing part, up to that part.
Yeah, that's sort of the basic. Yeah.
Basics. Is there any plan to add some advanced part?
Advanced part. So, in fact, very recently I gave some 2 lectures on amortized complexity at IMSC. And in fact, I asked them to record it. So what I will do is I will follow up and get the link for that recording and share it with you.
Okay, okay. That will be great help.
Sure. So just keep in touch with me. Send me an email later.
Okay, okay, okay.
I will get that and send that to you. Yeah.
Okay, and another question is that some word you have used, that good, average, all those things. You have said that that has different meaning.
Correct. Expectation. Yes. So this is my favorite question. So, when we say quick sort, it's a very important concept. So, basically books will tell you that quick sort is order n log n on average. Right?
Yes.
Because, merge sort, heap sort, these are n log n in the worst case. But quick sort is n log n on average. Now, what does on average mean? See, they don't either dwell deeper, or usually books actually they do dwell deeper, but they don't do a good job in the lectures I have seen. So it's important to understand what on average means. That's what I meant. These have technical meaning. So quicksort is worst case is n squared, but it's n log on average. Now, maybe I'll give you a rough idea what it means, right? So there are two versions of quicksort, right? What version of quicksort do you know or you want to hear about? There is a randomized quicksort. Okay. This tell me, how many of you know about randomized quicksort?
Actually, I started long time ago, 15 years ago. I forgot. That is the reason I asked.
Gopinath, knows, or Devi?
We have to take some pivot element.
Right. So you take a random pivot. I'll tell you how you do it. Let's take a random pivot X. That's step 1. Step 2 is compare and split all elements around X. And then the third step is, so let's call this all those which are less than X and all those which are greater than X, and X comes here. So now your array will look like this. Then sort recursively X less than and X greater than, because within X less than you have not bothered to keep them sorted. So the task remains to sort that recursively, and similarly you have to sort X greater than recursively, and then you're done. This is the algorithm. Okay. Now, what is the first step? Really, when you go ahead and implement quicksort, randomized quicksort, do you know how you will do it? Anybody?
We can take the first available element as a pivot element.
No, then it's not really random.
We can take any element as a pivot element.
Strictly speaking, what you do is you actually consult a random number generator.
Okay.
Go and ask for a number between 1 and n. It gives you, if it's a true random number generator, it gives you a number. Let's say it gives you some I. Then go to your array and pick the ith element as the pivot.
Okay.
Yeah, this is important. I'll tell you why. Because this meaning, when you say is on average, has a meaning based on how you do this pivoting. Okay. So in the first step, you pick a random element. So strictly in implementation, you go and consult a random number generator, get a I, because you are oblivious to the input. You have no idea what it's going to come. Because if you say first element as a pivot, then it's no longer randomized quicksort, it's a deterministic quicksort. Okay, randomized means that in the algorithm, there is a random step. You have no idea. An adversary cannot fool it based on that particular step, because some random element can come. Then you partition it and then sort recursively, right? So now, why is it n square in the worst case? Worst case, the recursion can become T of n. Your step 2 takes n minus 1 comparisons. Agreed? Because all you're doing is comparing everybody with X, that's all.
N minus 1.
That's step 2. Step 1 is not a comparison. Then after that, you're splitting and recursively solving. There is a recurrence relation here. But in the worst case, it's possible that everybody goes into one side, and then this can you recursively solve t n minus 1 and this gives n square.
Okay.
But on the average, what does that now on the average means? Can you make a
Yes.
guess? Yeah.
The selected element may occupy the center position.
Any position. So you actually do an average over all of them. The selected element may be the smallest, could be the second smallest, could be the third smallest, could be the fourth smallest. It has equal probability of that. That's really what it means by random pivot. So random pivot means the probability that that element is ith smallest is 1 over n for any I. So
Means
it's uniformly at random.
okay, means each split can be happened with probability 1 by n.
Correct. So, for example, the first step is n minus 1 comparisons. Let's ignore that. Now, it can be, if it is the smallest element, then it's going to be like this. Or n minus 1 plus t of one element this side and n minus 2 elements other side. So this is 0, so you can even ignore that. Or n minus 1 plus t of 2 plus t of n minus 3.
3.
Any of these possibilities. So if your element happens to be the fourth smallest element, there will be 3 elements to the left and n minus 4 elements to the right. That's what it is. So your recurrence can be anything of this type, each with probability 1 over n. So when I say average, you do an average over all this. That's what is n log n. Okay. So if you do an average over all of this with probability 1 over n, that is n log n. So that analysis becomes very non-trivial. Some books will have it. If you see this kind of thing, they will actually write it as t of n would be n minus 1 plus with 1 by n probability, it will be t of k plus t of n minus k or something like that. This quantity, if you solve with complicated recurrence, it becomes n log n. So when you say n log n on the average means for a randomized quicksort, it is averaged over all possible choices of the pivot in the first step. And actually there is a percolation of these averages in the recursion as well. Okay, so it's a lot more complicated. And that's what average means. Now, what is nice? So there is another version of quicksort, which is a deterministic quicksort, where you just say, I take the first element as a pivot. There is no randomness in the algorithm. That has a problem that if the input is sorted already, then the split will be 1 plus t of n minus 1 kind of thing. It will be n square. Because if you take the first element, here you'll be lucky and it becomes the smallest element. And then everything goes into one side. It will not be a nice split. But there also there is an average performance, but that is average over all possible permutations of the input. Which means in the input, if the first element happens to be the first smallest, second smallest, third smallest, and you do over all possible input permutation, take the average, that average is n log. Okay, so this is what I meant by when you say it has an expected n log n or on the average n log n. This is a pretty loaded term. And often people use it. But important thing is quicksort works well on practice. In very, for most inputs, it's n log n, and this can also be theoretically analyzed. Okay, does that give you some idea?
Yes, sir.
Yeah.
I got it. And I have to say that in greedy, What other problems I should focus on?
Meaning, I mean,
What are those other problems in greedy?
that's a very broad question because, um, as I said in the videos also, very few problems, some sort of scheduling problems, um, minimum spanning tree, Huffman code. There are a few problems where greedy gives you optimum. Most often, it does not give you optimum, but um, but greedy actually gives you good approximation algorithms and so on. So there are approximation algorithms where greedy gives you something where you can analyze and say that how good the optimum solution is compared to optimum. So what other problem you can focus on? I don't know. I mean, because
Yeah, actually, in the context of, I am saying that you started with scheduling, that job scheduling problem
correct,
in dynamic programming.
right.
Then you converted, you are going to greedy.
Yeah, it so happened that in that case,
Uh,
see, dynamic programming is more robust because
yes.
you are really trying all possible solutions and it's likely to succeed. Greedy, if it succeeds, it will be faster. That's the point because you're not trying everything. But when will it succeed? Okay, there is a notion of what is called matroids. Okay, that's also there in, it's a nice combinatorial object. It used to be, I think, in CLR's old edition. I don't know whether it's still there. Um, Matroids sort of generalize, you know, where greedy algorithms work. I'm just throwing some keywords here, but so that you can, for more deeper reading, you can go check what matroids are. Matroids is some combinatorial object. And finding a maximum independent set in a matroid is an interesting problem where greedy algorithms give you work. That actually capture what problems for which greedy works. So I think, for example, second edition of CLRS has a small section on greedy matroids. I don't know. The current section, they might have removed it. I don't know.
If I want to start like this, means what you have done in scheduling, job scheduling, then you are going to greedy. So that kind of problem means if I will start with knapsack or like that, then I can do that.
No, but the problem is for knapsack, yeah, you can try dynamic programming. Again, greedy, we do dynamic programming. Greedy does not give you optimum in knapsack. There are examples, yeah.
Okay, okay. Means we can do it comparison and what is better or what is not. Okay, that I got. Thank you, sir.
Okay. Okay, so hope you found this course useful. So good luck on your test tomorrow. And some of you, I will again meet in the Viva, not for everyone, but for some, we will send you an email um, about fixing up a time to discuss. Otherwise, there are no other comments. We will wrap up. Okay, so if there are no questions, then thank you and see you sometime later.
Sir,
Yeah.
tomorrow we can use open book and whatever notes we have.
Yes. Yeah.
Okay, sir.
But write it in your own words. That's the main thing.
Yes, sir.
Yeah.
Yes.
Yeah. Okay, thank you then. See you next time.
Okay, sir. Thank you for your beautiful course.
Thank you. Yeah.
Thank you, sir. Thank you, sir.
Thank you, sir.
Bye for now. Yeah.